Well, hi, good morning, and welcome to my shop. I'm about to start work on this Strauss AM/FM radio. But if you're a subscriber and you've been watching videos as I post them, you know I've been working on bench tube testing, if you like. Well, look, all that stuff is still back here. Not to worry, I'll be back at it. But for now, I think for me, anyway, a big change is welcome. And the big change is there are no tubes in this radio. This is an early, can I call it early? 1970s transistor radio. So let's plug it in and see what it does. Or maybe we're going to see what it doesn't do. Plug it into my shop supply here, and we'll start it off with the dim lights. What I would do is go down to my low. This is a 25 watt bulb, so we're just running the power through a 25 watt bulb. These things draw almost nothing, so chances are 120 volts are going to show up on this in any case. But if there's a fault in here of some serious amount, and there isn't because I've already have this plugged in the wall, if there was, my light would come on and we could all clap and be happy after that. So switched off. Off is off. Okay, and we have 124 volts supplied to it. It will drop slightly when I turn it on. Let's just check these controls. Tape, AM, FM, automatic frequency control. We'll put it on AM. Tuning tunes. Here we go. Dirt in the control. Oh, hear that hum? Probably from the volume control slider being off, being lifted by dirt, the hum. That basically opens the circuit, turns it into an antenna. That's kind of what I think is happening there. Oh my gosh, this is pretty bad too. So they're talking about sports. It's probably 590. 590 is a very strong signal up here, 590 AM, and I see on the dial here it's about 610 on the dial, so that's almost certainly 590 there. When I listen to it, it sounds to me like it's being cut off. The sound is being cut off, as if maybe one of the transistors isn't biased properly, or something of that sort is going on. Or maybe the power supply in this is weak and it's just lost its voltage. Something like that is going on. I guess clipping would be the right word for it. I really should use that word. So we have an on. I guess that's the on-off light there. I can hardly see it when I'm looking down the way I'm looking at it. But these must be the band indicators. I don't see them coming on here. It's FM and AM. Yeah, I don't see these doing anything here. Okay, so it's just AM again. Sound out of both speakers. When I looked at the schematic, which is down here, the speakers are actually hooked in series. One works, the other should too, I guess. Okay, FM. Now the owner of this radio, of course, like anybody, would be more interested in the FM side of this. They really want this radio to be a daily working radio, listening to something on FM. Let's see what we can find here. This will be the FM antenna. This wire hanging out here. Let's see what we can get. Not much. That's really very, very, very quiet. Okay, there's the FM hiss, I think. Maybe not. Absolutely nothing. Nothing whatsoever. Well, I think that's the challenge right there. Absolutely nothing out of the FM. It's a long shot. It's just the switch is dirty. That's a bit of a long shot. Well, maybe not. So I'm just checking how bad it is. It's bad. It's bad. It's bad. Okay. There we are. AM kind of working. Sounds kind of clipped. FM no show at all. So I've had the back off this briefly already. So we'll just pop these screws out. Strauss. So you find radios that look like this style, by the hundreds. All kinds of manufacturers' names on them, like Strauss, but I don't think Strauss built this. This was not built it's made in Japan. So Strauss would be probably the importer, would sign a contract with this factory in Japan. Japan factory would make all these. Was the Japanese manufacturers never named? I don't know if you ever noticed this, but this is what I noticed, that the Japanese, from this period of time when the Japanese home entertainment industry was roaring ahead. By the way, that was something the Americans decided after the Second World War. Did you know that? After the Second World War, the Americans decided that they would take the military electronics industry for themselves, and they would hand off this is what I heard, I don't know if this is really true, they would hand off the household electronics industry to Japan, because Americans had taken over Japan and they needed to get people working quickly. So that's what I heard. True? I don't know. Who knows? Let's get this back right out of here. Lots of discrete parts here. Should be easy to work on, I think. So we're going to have to take this chassis right out to get at what we need to get at. This may not be the easiest thing here. Let's see. It looks like it's on these posts with nuts. It looks extremely awkward to get in there with a screwdriver. Yikes. And then what? When it comes loose. Now, is this? I can see the radio pointer is sliding on this panel. Once in a while, these radios, the pointer does not slide on the chassis. It slides on something mounted to the cabinet. Now, when you pull the chassis out, it literally can break the strings or rip the pointer right off the front. I've done that. I don't want to do it again, so I'm being a little careful. There's also some wood screws holding in 2 blocks of wood. There's only one screw down there. There's a good chance lots of things are glued in here. I mean, I can see glue here, so I won't be taking those wood screws out. You pull this out and the speaker wire is only so long. You might have to bring the speakers out right away too. They're held the same way with the post and the nut. It's a long post and my nut drivers probably won't go down over that. Oh my gosh. Okay, so right away, it's tough. It's tough already. Okay, so this radio is now like my cat. I have removed his nuts. There we go. Let's pull them out nice and gently because surprises happen at this point. Surprises like you didn't take the knobs off the front. Now that would be a bit of a surprise. So, these knobs. Okay, let's try it again. Watching for wires going tight. So the speaker wire here is getting tight right away. Sometimes these are on little plugs. Most of the time, no, they're soldered in. So my options are leave the speakers where they are. Remove some wires, extend wires back to the speakers. Use an alternate speaker while I'm working on this. These are 8 ohm speakers hooked up in series. So I could probably put an 8 ohm speaker on here, no problem. But maybe I shouldn't. Maybe these speakers themselves may have trouble. We can only detect if we use them. Probably the easiest thing I can do is cut away these 2 wires, abandon the speakers in the cabinet, leave them there, use an alternate speaker while I'm working on the radio. And towards the end we can always I can always test the speakers separately too. So so I don't lose track of where they came from, I'm going to cut the wire at the speaker. So later on when it comes time to put everything back together or even while I'm working on it, it's quite clear which wire is the speaker wire. Because I know the more chances I give myself to make mistakes, guess what? The more mistakes I'm going to make here. Okay, so there it is. There it is. Wow. Okay, let's get rid of this cabinet. Here we are. Okay, so right away my eye is drawn to this thing. Right here. What is that thing? Don't know offhand. So I'm quickly looking for anything that might be burned open, any resistors that are darkened or blackened, or just anything that looks like it's taken some heat. Taking too much heat. And everything looks pretty good. So I look at the top of all these capacitors and see if any of them are swollen up. All these capacitors are questionable. Those are all electrolytic capacitors. They may have to be changed out. Now, the problem is, see, the AM part works. Where's the AM? This is almost certainly the, well, there's 2 IF strings in here, isn't there? There's this one and then this one down here. There's lots of different ways you can mix AM and FM radio circuits to come out with an efficient design. I see transistor, 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 transistor there. I don't see any in between over here. So a lot of these IFs, they use the same amplifiers. On AM they run them at 455 through the IF here, but on FM they'll run them at 10.7 through these. This is probably AM, there's 3. This is probably FM, there's more. There's a 4th one. So this is probably the FM string. Probably 3 of these are IF, I'm not sure. One of them will be some kind of balancing thing for the discriminator, the FM discriminator. So looking up at the very front end circuits here, we're not looking closely now, we're just taking a bit of a long look at it. Again, I'm looking for any burned parts in here. Anything that looks like it's overheated. It just doesn't look right to me. And I don't see anything like that. Everything looks pretty good. I see there's another. Oh, this one says right on it. Well, it says 10.7 megacycles right here. Now, hopefully the circuit diagram, let's get the circuit diagram here. That's a little small. But even from distance, you can see that there's a section here and then another section here, and that almost certainly relates to this and that. This board has the tuning capacitor mounted on it. Does that show up in here somehow? Goodness knows. But with this, I can sort out what these guys are when the time comes. Time comes to tune them up, and that might come kind of quick. It could be all that's wrong with this radio is it's just so far out of alignment. I kind of doubt that myself, frankly. AM, maybe that's the case, but FM, I think there's something busted in there. So probably our best approach on this is to really first examine the power supply, because of the clipping sound I heard. It might be an indication the power supply is not doing the trick. And why would that be? Probably this big capacitor. Not too good. This is probably the rectifier. This is probably a selenium rectifier right here, and that's got to go. We got to get rid of that. The selenium rectifier, if it's bad, will have a large voltage drop on it, and then it will rob the rest of the circuit of its intended VCC voltage. Just follow the power supply for a second. The power cord comes in. It's important to look at this stuff a little carefully, because this is the kill you part. And you know what I'm going to do? I'm going to put this down. Oh my gosh, how many of you realized I did all that with this thing still plugged in? Shame on me. Now, quite a few of you comment that you appreciate it when I put my mistakes on video. Here's one. That's one of the worst. That's one of the worst mistakes you can make. I totally forgot this thing was still alive. Wow. Fortunately, the high voltage stuff, the 120 volt stuff, is contained to a small area of a radio like this. It is not spread all through it normally. Wow, I'm a bad boy. How did I make that mistake? Part of it is there's no big warning light going here. Unlike my meters over there, my power supply doesn't beep at me to remind me it's on. I think I've got enough going with this. You know, I'm just examining why it is I nearly killed myself here. That's what I'm doing. Well, you know, like I have certain practices and I just didn't follow them. One of them is before I do anything, I usually unplug this no matter what. Shame on me. Bad boy. No dessert at dinner tonight. Okay, now I'm safe though. Let that be a lesson to you all. Just lucky I didn't get a big whopping lift off that. Every 120 volt shock can kill you. This is, I had trouble believing this because I've gotten so many of them over the course of my life. I've probably gotten, I wouldn't be surprised if it's 30 or 40 120 volt shocks over the course of my life. Most of them when I was a kid. I'm still here, but I did have someone, Dr. Pozak from the Ontario Coroner's Office, explain to me in detail that people die at 120 volts very regularly. Put the fear of God back in me. Fear of electricity. Not fear of God. Fear of electricity. Let that all be a lesson. Let that be a lesson to anybody who needs it, including me. So, what are we going to do now? So we have an AM that's sort of working and FM doesn't appear to be working at all. So maybe the first stage, like I said, was we'll check the power supply without getting shocked. Right, that's where I was when I was thrown off. Switch. So that's the power transformer. These orange wires are the high voltage going into it. These are the low voltage. I'll take it back the other way around. Wait a minute. Wait a minute. Okay, so these orange wires are going to the light on the front panel. These wires are carrying the power into the transformer. Coming out on the other side is these blue wires here, and they almost immediately encounter this thing. So let's look on the schematic now and find out what that is, because if that is what I think it is, it's got to go right away and be replaced. What do I do with the radio? Okay, we'll take a closer look at the schematic here. There, fantastic. Except we're not looking at the power end, we're looking at the antenna end of the radio. The power end is going to be down here, way down here. Here it is. So let's find the outlet. Find the plug. There's the plug. What do we got going here? So if you notice, the 120 volts never makes it past the transformer, and that's how these radios work. Everything in the radio is powered after that transformer. So basically, they've drawn it in the weirdest way. Oh, maybe not. We got a 680 k ohm resistor running from one side of the line to what shows as the chassis. Okay, so that's a really important observation. I'll show you another. I'm going to show you right now because it's worth seeing this right now. There's another way to determine that there's something going on with this radio. And that is, believe it or not, these knobs. These knobs have a big hint in them. See the long shaft? The long shaft to reach through the front panel down into the metal knob, right on the front of the radio, right? The metal knob. You pull the knob off, this metal knob does not protrude. You can put your hand like this and not touch it, because there's a chance this metal knob and this frame is 120 volts above ground, and you may not be. So so when I pulled this off, I didn't say anything, but that was a hint already. There's something going on here. Just a hint, though. It's not a guarantee. Let's go back. So 680 ohms, 680,000 ohms, a big resistor. So chances are you wouldn't get much of a shock if you plug this in so that this line is live. This is a great radio to show you something here about this. Switch is open. Can this point be live? Sure, it can be live back to this prong. If this prong, this is a non-polarized plug, so if this prong is plugged into the 120 volt side of the outlet, 120 volts coming across here. You might say, well, that's easy. We'll just rotate the plug. So you rotate the plug with the switch off, you measure here, 0 now. And you think you've made yourself safe. But the problem is when you close the switch, 120 shows up again. This is a great example of the hot chassis issue. This chassis not being super hot with this big resistor here, but it still is part of the picture of hot chassis problems. You see, I can explain this here so nicely. If you close the switch and take tests, you'll be maybe inclined to rotate this plug. You rotate it, repeat the test, you'll see the voltage has disappeared. Then you operate the switch to its other position and the voltage will reappear. You cannot get rid of it easily on these hot chassis radios. So, okay, harped about that enough. That's enough harping. So, coming on, now what's the voltage of this supposed to be? So here it is coming over this, see, first thing it runs into is this rectifier here, SR silicon rectifier. That's what SR is. This has to go right away. So I'm going to make up a little diode rectifier to replace this guy with and install it. But before I do that, I should try to measure the voltage drop across this thing. How would I do that exactly? You look at the voltage remaining coming out of it, but they haven't written. Have they written it here? So this capacitor is a 16 volt capacitor, and this one is a 20 volt capacitor. So we can guess this voltage is below 20. Come on, can't you just tell us here what it is? Maybe it's up here further. Somebody tell us the voltage. Kenneth, what is the voltage? There's another 16 volt capacitor there. Oh, look at that. So all the sound going through the speakers gets there through this capacitor, right? And that's a typical thing on a transistor radio. So, you know, if this capacitor is weak, the speakers are weak. Nobody's telling me the voltage. Is it written in a note somewhere? That would be unusual. Okay, so we can do this, though. We can make some assumptions here. Well, one is this transformer is doing what it's always done, and always will do. 120 volts on this side is going to make a certain voltage on that side. That voltage, we can kind of, in our heads, figure out what it should translate to DC-wise, and it should appear over here. Well, that's a bit of a long shot, isn't it? I'm going to take a measurement, and I'm just going to be left scratching my head. Somebody give me the number. Now what's happening there? Where they got the R226560. Looks like they forgot to write the value when they prepared the schematic, and then somebody just pinned it in. 10 volt, 16 volt. Well, darn it. No hint. So just to be really clear, I'm frustrated because they aren't saying what the voltage should be on the output of this guy. Now, does the transformer itself have any information to share with us? Probably not. PT414. Maybe I can look that up, but I'm not going to bother. I mean, this is a really obscure. Yeah, I don't see anything on there. It's a guessing game. Guessing game from here. We'll start. You know, why guess? You know what I'll do? Here's what I'll do. I'm going to get rid of those diodes, no doubt. I will measure the output voltage of the little power supply here. And then I will change those diodes. Then I will measure it and see how much different it is. My guess is this is 12, 14 volts. Something like that should be there. That's my guess. Okay, out you go. So if we're going to measure this, all of my... No, I was going to say all my meters are really busy, but I could free up my main guy here. The tube testing experimenting I've been doing has required an awful lot of meters to monitor stuff, which has been a problem in itself. So we want to find out the output here. We'll go to 20 volts AC. May not be enough. I want to get on the end of these blue wires, which are tucked in there so tight I can't really see what they're doing. I think they're attaching right to there and there. And what about catching the output of that? Blue wires are attached to the two end pins here, and the two end pins, there's 4 pins on this thing, the two here are the output side. One side grounded, one side carrying the voltage forward. Wow. You getting a look in there? So my best bet is to measure everything. I'm not going to do it with this clip lead. When in doubt, measure everything. AC, ready to turn this back on. Remember you have it back on. Remember it's switched on. Switch off, of course. On with the protective bulb, just in case. Switch on. And 122 volts. The light is on. Now we want to measure the voltage, well, here and here. Put this where I can see it. That was kind of what I was guessing. 15 volts AC. That's what's being applied to this diode. If I got the picture right, I may not, I should be able to flip to the other side and read the DC coming out. Try not to short this out. This would be exciting if I put a short on this guy. It's almost the same voltage, 16. Do you believe it? 16 DC. That sounds about right. And I'll be going into a filter. Probably this capacitor and this one. Coming out the other side, filtered. I didn't hear any hum in this radio. Oh, I don't have speakers hooked up. Is that a bad thing to do? I don't think it's a terrible thing to do with a transistor output. Let's hook up a speaker and see if something's happened already. I haven't even done anything, but you know, things happen. Okay, I'm soldering on some rather lengthy extension wires here. I picked lengthy wires because that's all I got. Handy. I'm going to solder them on so there's no trouble. I have the feeling this is going to be a couple of days working on this radio. Now I'm happy to do a transistorized radio because I've had my head in the tube world here for quite a while, like basically my entire life. But would you believe my education is actually on, of course, transistorized digital equipment. Oh, really? That's right. Oh, I gotta hook it up now. Hook them up. Now it's just one speaker and it's one 8-ohm speaker. So we're just going to go on the basis that that's not a problem. It might be. Changing from 8 ohms, from 16 ohms to 8, that's a pretty fair jump. Just get a little bit of temporary tape here. There's a chance one of these speaker wires is ultimately connected to the chassis and ultimately connected to the plug in the wall. I'm not sure of that, but it's funny. You might think all those big old tube radios with their high voltage in them, those guys are dangerous. Yes, they are. Lots of dangers in life. These things are not without their dangers, and they may even be more subtle, hidden, more liable to bite you. Like I almost got bit from this one already. Like, I think the basic rule here is if you're going to be a parachutist and you're going to jump out of an airplane, there's a good chance you're going to do that until you're dead. I mean, there's a question of odds here. Well, I'm not jumping with a parachute. I'm in a shop with electrical stuff all over the place. There's odds I'm going to get a shock. If I do this long enough, I will get one. I suppose, you know, in a commercial setting, you would set up an arrangement here and have procedures to make it virtually impossible to get a shock. Chances are, though, people won't follow those procedures because they are too inefficient and troublesome. An example would be, before you hook up any test gear to the item under test, You shut off the power, disconnect the plug, hook up your test gear, put the plug back in, turn the power back on. That is a standard procedure. Does anybody really follow that? And okay, anyway, we have the speaker hooked up now, so we can listen while we poke. And we found out 16 volts DC appears to be sitting there. We want to find out about the hum level in this radio. So a little bit of a larger speaker than the one that comes with the radio. So if there's a hum, we should hear it. Now, ooh, don't break the pointer right away. We're on AM. Now, you need to be very careful because you can hear hums when the radio's tuned certain ways. So, do you hear a hum? A hum kind of coming with the sound? No hum. I'm not saying I can explain that either. A little scratchy, eh? So when I grab these knobs now, this is out on my bench, I am grabbing one prong on this plug every time I do that. And yeah, okay, 680K resistor there, but let's just pretend it isn't there. That's kind of what I'm doing. Okay, I'm taking a 680K resistor, holding it in my hand, and touching it on the prong. Get that in your head. FM. It's FM. This radio just goes... Is that what just happened to it there? Let's go back to AM. Over to FM. No, it's just totally quiet. Maybe I didn't give it enough time to... something to lift up. So let's think a little about this now. In terms of the AM radio, all the circuits appear to be working. They might be a little out of tune, but they all seem to be working. So that means anything that's utilizing those circuits is passing through working circuits. When you look at the radio, that's just the volume control, which I'll clean up in a minute. That would mean all these amplifiers are working in the IF. 10.7, eh? So a little difficult for me to trace 10.7, but I could poke around and try to find a 10.7 signal somewhere in here. I'm just thinking about troubleshooting down the road here. And try to listen to the FM signal as it's traveling through its IF amplifiers. Let's get back to this problem of the... When these things start to fail, they get hot. They get really hot. These things being the as cool as a cucumber. And look how this is made. Just something interesting about what I'm seeing here. Maybe I won't change it right away. So we're looking down at it. Oh, what happened? What happened to my camera? Hey! I must have... Sometimes I step on the camera cord and it gets pulled out. I don't know. Hey, my camera's gone bye-bye here. Okay. Sorry about that. I'm just staring at a blank screen. I don't know what happened. Hello, little camera. Okay, well, I had to reboot my computer to get this camera to work again. Let's take a look at this part here. It's got a big positive down there. Yeah, no doubt there's a negative right behind it. We can't see it. And these two sides are the incoming side, and this is a bridge rectifier. The part I wanted to show you is looking down at the top. So I think what I'm seeing there is a metal can with a spring pushing plates together, pushing on those plates. So, and I've never seen, I'm sure that's a spring. I've never seen this before. These things are usually not quite so open. I think just a series of plates with oxide on one side, I believe, is how this works. So there's some kind of voltage drop happening there. It can't be too much or this thing would have gotten warm. It didn't get warm, so I'm just going to leave it as it is. It's interesting it has that spring. That gives it some kind of like active pressure. Kind of looks like it's soldered in there. I don't know. Interesting though. So the sandwich appears to be okay for now. If there was any sign of heat in there, I'd be anxious about it. But there's no sign of heat, so we won't be anxious about it. No. Could be too, as the years went by, this kind of rectifiers were improved upon, so the chance of them flaming out is lower all the time, perhaps. So no hum. It kind of suggests the power supply capacitors are doing their job. That's good. Why no FM? So at this point I have a couple options. One is I can pump a really powerful FM signal into the front of this radio and see if any of it comes out the back of the speakers. You can try that. That's pretty easy to do. Another thing is to try to listen to the signal as it's traveling through the radio. I could do both those things. And Jim, the power is on to this thing again. In fact, it's switched on. Oh my God, I'm terrible. You know what? I'm leaving the room, and when I'm coming back, I'm not remembering the status of things. Maybe if I just leave it making a little sound, that would be better. I won't forget. Or it could just be alignment issues, and I could fiddle with the alignment here and see if suddenly the FM comes in. I don't think that's really sensible, because I think if it were just alignment, we would hear some kind of something that would make us think it's almost working. That's what I want to say. Let's start with the oh so powerful FM signal being shoved into it. So to do that, I'm going to use this piece of equipment here. We'll fire a strong FM signal into the back of this radio here. As soon as I get this all sorted out. We don't need this. Stick it in here. It's out of the way. Switch on. Now this guy will put out a signal at 100 megacycles, roughly in the middle of the band here. The FM antenna amounts to this wire. So if I clip the output, I'm not going to do it right away, but I can clip the negative with the negative onto the chassis. Wouldn't that be the place to put it? Time to consult this again. Can we put a ground on the chassis for the test equipment? That is the, whoops, sorry about that. That is the question. So we're reminding ourselves what we saw here. $680,000 ohms. Oh, that's a big, big resistor. So I'm powering this radio right now through that plug there. into another isolation transformer. So it doesn't actually have a tie back to the hydro system ground. But as soon as I bring some test equipment into the picture, I'll be applying that ground. So conceivably, I would put, this is what would happen here, I would put a ground on the chassis, and that 680 ohm resistor will get 120 volts across it, depending upon how that plug is plugged in. Except my plug is plugged into a isolation transformer right now. So that wouldn't happen. So I should be able to put a ground. I should be able to put a single, a single ground connection anywhere in here I want. A real ground anywhere, one, and get away with it. I'm not, what am I doing? So I think it's quite safe to put the ground. Now what if that resistor is open? Well, it's even safer. What if the resistor is shorted? That's just not likely. What if something else is shorted? We'll probably find out pretty quick. I can rotate this plug anyway, this way and that way. It shouldn't make a difference, but I can always do that. If this were plugged right in the wall, I would be a little more hesitant about doing this. Kind of thing, get out the voltmeter and fool around, bearing in mind what I said earlier about which way is the switch. Okay. I think I'm okay. I think I'm okay. Find out now. Lots of resistors in here. Oh, sorry, I'm not showing it to you. So this is the RF lead coming out, and this is done according to requirements for wiring up the output. And look, there's a resistor in the ground lead. I can't remember doing that. It's a strange looking thing under there, isn't it? Well, maybe I just forgot to nip that excess piece of wire that's in there. Well, just ignore it. Yeah, I should not look at things so closely, maybe. That's a mistake. Never look at your previous work closely. Ground onto the chassis. So we know why it's making these sounds. Because there is voltages there and pressures. Oh, some of the hum just disappeared. The buzzy hum. And this will go on the antenna. The antenna being this wire. No. The antenna being this wire. Onto the antenna. Okay, we survived that. There should now be a fairly strong FM signal around 100 pumping into this radio. Definitely on FM. Oh yeah, sorry about that. Didn't mean to. Can we find anything? Now there's an RF level control. I'm sure they have gone past the 100 point. I like to ask Shirley a lot of questions. Let's see. So 100 is just to the right of the middle of the dial. In the middle of the dial is about here, just past there. Should be in here somewhere. Okay, make sure this is full blast. Okay, it was down. Okay, that's full blast. I get the impression this guy's as dead as a doornail. Okay, radios can be totally dead because they have no local oscillator operating. So I'm going to set up the SDR and we're going to look for signals coming out of the radio that might give us an impression of yes, it's working or no, it's not. So give me a few minutes here. Okay, a little bit of fiddling around there. So what you're looking at now on the SDR is the SDR is receiving the output of this guy. That's what you're looking at, and that's what you're hearing. So I can tune it around. I'll tune it more slowly here because the SDR can't keep up with it. So this is tuning the output frequency of this generator. And you can see I can set it right where the SDR is tuned. Right on 100. This is quite accurate, so it really is around 100. Nothing to do with this radio yet. So that's being picked up. There we are. There's proof positive finally this is working. Now what happens if I put on this? Will it kill it? No. Good. So we should be able to find a local oscillator with this now, I'm pretty sure. So first we'll tune this to something other than 100, so we don't have to listen to that. Now, let's think again. This is 100, and I don't know that. It's 10 more megacycles above where the local oscillator is. So I'm going to put this where I think it would probably pick it up, right here. And I'm going to tune the radio and hope to see it go by on the SDR. Not very hopeful. Not very hopeful. I don't see anything at all. So either this is proving there's no local oscillator, or it's just proving I don't know what I'm doing. It's one of those two. That's the problem with a negative result, you know. What I'm pondering in my head here is, should I hook up the scope and try to look at this with the scope to see if I can find it there. It's probably obtainable on these plates here, or near those plates. Those are probably the local oscillator plates right there. So what if I just do this? What if I take this, put a clip lead on it. This is like hooking up an antenna now. Okay, it's convincing that it's working. And I put this right where I believe that local oscillator is. This is a fairly low impedance. If I hooked up both wires, it would be low impedance. It's not the way I'm doing it. I have a feeling this is a stupid thing. I'm going to do something stupid here. Why not? I'm going to touch the plates. Ooh. Make some noise on the radio. This is probably the craziest thing in the world you can do. Sometimes you can tell when I'm running out of ideas because they start getting pretty crazy. This is crazy because hooking the clip lead to the plates, if it was oscillating, it isn't now. Maybe I picked the wrong set of plates. Maybe it's these. No, this is just crazy. It's crazy. Crazy idea here. Is there a local oscillator? So now we'd really want to try to measure it, or like detect it with a more direct method. I'd have to know where to go after it. Maybe it's more in this circuit here, not over here. Let's poke around here with the yeah, I think maybe I was in the wrong spot on the radio. Okay. Some nice coils in here. Well, it could be tuned way off from where we can see it. Okay, there we go. Normally a local oscillator is a pretty strong signal. I usually have no problem picking it up and nothing. So this is really quite suggestive, and the way the radio is operating or not operating, and what I'm doing here is really suggesting there's no oscillator oscillating in here. How can we absolutely determine that? Absolutely. The difficulty here being every time you do some kind of contact measurement, there's a chance you're shutting down the very thing you're trying to measure. In a radio like this, we will study up here. So a local oscillator is introduced somewhere in here. Let's see if we can find it. So, we're coming in from the antenna, transformer going through this amplifier. Look at that, TR1, VC1. Those two tunable or adjustable capacitors. Wait a minute, one's got an arrow on it. Okay, so one is the tuning capacitor you tune when you turn the control in the front, and the other one is the trimmer. So you can actually see it there. TR trimmer, TR1 trimmer 1, VC1 variable capacitor 1. That's what that is. So so this is tuning the radio signal right here. So over here I would expect the oscillator to be. So this second VC2 must be the oscillator tuner capacitor with the trimmer, TR2. And that's paralleled right across this coil, which has got some resistor there, 6.8K across it. Look how they snuck that into the schematic. So that was an afterthought. Some kind of afterthought there. Maybe it was left out in the original drawing and the engineer picked up on it and said, hey, you've left out a resistor. I don't want to redraw this whole thing. Well, just jam it in there. Okay. You can even see it's handwritten, 6.8K. Could be they made a number of radios without that resistor and then started making them with that resistor afterwards. So that's got to be the local oscillator right there. That coil. L3 and the two capacitors. That must be it. So what's going on with this transistor now? This would be the oscillator transistor, I would think. And the output from this one, yeah, it's a little over my head here understanding how these transistors are connected together, but I think basically that's an RF amplifier. This is the oscillator and the two signals are getting mixed up. Is that transformer? So that's the transformer that's on that board. We were looking at the only one with tape on the top of it. All the rest are inviting. Come, twiddle my slot. That sounds really filthy, doesn't it? But not this one. This one's leave me alone. Possible during the manufacturing process they put tape on that at some point to keep people from accidentally turning it. Maybe that gets adjusted early in the. Maybe that board is built on one bench and the other one's built on another bench, and the one bench had some Scotch tape available and the guy stuck it on top of his can before he pushed his finished circuit down the line. Geez, I'm good at making up stuff. That's my claim to fame. So if we want to find a local oscillator, we're going to find it here. A good place to look might be down on the, oh my gosh, this right on this output here. Wouldn't it be on this line? This line comes all the way over to here. It goes in on the base of Q202. and it starts going through IFs. What's going on here? There's only one. Oh, there's the other one down here. So what they're doing here, I think, you see this transistor is going to amplify the IF for both the AM and the FM, but there are two quite different frequencies. The AM is going to be 455 probably, and the FM is 10.7 probably. You know what? I'm making assumptions on those. Probably a pretty good assumption. So one set of coils is ready to resonate at 450 kilohertz. You know, I'm going to guess those. The other set of coils, I'm just guessing it's these, is set to resonate at 10.7. So I'm looking for hints on this. It's quite a funny little deal there with those transformers. You can find a little more transformation in a transistor radio because there's more current. These are more current devices than they are voltage devices. Well, if this is the local oscillator and the radio signal, they must have mixed them at this point. So what's coming out of here then is signals including at 10.7 if there's something tuned in and a local oscillator is operating. There would be a radio signal at 10.7. So I go back up here. I may be saying things wrong. I may have said local oscillator at 10.7 a couple of times. No. 10.7 plus the target frequency, or maybe even minus. I don't know for sure. I don't even know if it's 10. There's no hints on this thing. No hints. Maybe that suggests that it's definitely standard. So, you know, where else? Is there anything written on this anywhere? Thank you for that. Anybody sign this? No. You see, there isn't even a name of a manufacturer on here. So here's the AM antenna, and we can see the output is, well, it's right into there. Where's the other side going? To the ground. This must be, this dotted dash line must be the ground going all the way around. Or the chassis or something of that sort. So that's definitely AM coming in down here. AM, what are they doing with all these transformers? I don't know. And you see it's injected into the base of this transformer Q203, transistor Q203. So this guy, I don't know. Look, there's voltages written there. 9 volts, 12, 13 volts, 7 volts. Voltages all through here. How come they didn't bother telling me what the power supply voltage is supposed to be? Is it right up at the top here somewhere? No. No, that issue's long gone, Jim. Give up on it. So if we want to pick up the local oscillator, it really doesn't come out. It shouldn't. It might, but it shouldn't come out of here. It should be near this. We should find it around here. Find it around this transistor. Find it around that coil right there. L3. Where is L3? If we find L3, then it's right near this T2. L3, T2. But, you know, nothing's going to be labeled on this radio. Like that. L3T2. I really sound like I know what I'm talking about, but believe me. So this is the IF circuit board. Yeah, let me just pull out. I know it's out of focus, but that's the circuit board. This looks like the receiver board under in here. So out of here comes the IF signal that's heading into the IF. That's my guess. So over here we would find 10.7 and stuff like that, but we're not going to find the local oscillator. It's going to be contained over here. I already hunted for it with my sniffer coil. No luck. So there you see some coils down there. There's one there. You know, those are beauties for issuing out a signal you can grab. show on the SDR. Look, there's this curious transformer down here, coil thing. I don't know what that is. We can go with that. Let's sniff this thing out again with a coil before I start touching parts. Again, if the fact is the local oscillator is not working, and you know, it's really quite possible that's the situation. I am never going to sniff it out here, no matter how hard I try. Up in here. I should be able to see it there. Let's flip this right up. Do it like this. I think, you know, really I'm coming to the conclusion there just is no local oscillator. If they don't use 10.7, they'd have to use non-standard everything in this radio. I can't imagine that. Well, all I've really got left now is direct connection. I'm not happy about doing that. Direct connection between circuits in here and my SDR radio. I'm not happy about that. This coil is useless at this frequency. Can't imagine that. Somehow I got to get to grips with this local oscillator thing. Bring in another radio. The SDR has that nice display on it. That's why it's so valuable in doing this kind of work. A regular radio only shows you what it's receiving at the frequency it's tuned to. So what I was thinking was I could use a regular radio to pick up the local oscillator out of this one. Just tune an FM radio. Let's try it. Okay, there's really no reason to think this is going to work any better. It's just another FM radio. But let's give it a try.
To shock somebody and load them in a vehicle. So right from the get-go, this was a very unique case.
So they're trying to track down the suspects. They're also still trying to determine the motive for this kidnapping. They confirmed again this morning, as far as they're aware, no ransom demands or any other kinds of demands were made by the attackers.
I should do this with this on here somewhere. I don't want to hook it to anything in particular. How about that?
Like a third grader in art class.
It's going to take a while. So this is my signal transmitter here. It's putting out a blast.
Also makes me think.
I saw that on the SDR earlier. I'm not going to get to 110. Good enough. Now we're going to tune this guy down. Hopefully cross that frequency with the local oscillator here. Okay, we're really at the point where I have to actually go and look for this local oscillator for sure. So we're going to do this using the scope. Could you hear the frustration in that? Okay. See, I have this all worked out, but not anymore. I have to come up with a new arrangement for my SDR radio because that one did not work out. Okay, now the scope, it's up there. You can see I am connected without clipping this anywhere for reasons that may be stupid. I'm going to attempt to see something in here. Let's get this out of here. The sound you're hearing is coming from this speaker. And what we're looking for is a signal appearing on here. But it's fairly sensitive. It's disappearing off the screen when I do this now. I'm just kind of randomly going in here. Again, without the ground connected, because I'm not quite sure yet where to connect the ground. Well, it's certainly having an effect on the radio. Line. Why did that disappear completely? We're on AC here. I have to put the ground on to really see what's there. There we go. Beam finder. Oi! Wow. Okay, so I picked some whopper of a voltage here. Oh, look at that. It's a huge thing here. That's 5 volts per division. How do you get something that big? Woo-wee. How do you do that? That's amazing. And probably if I hook the ground up, we get a little bit of a different reading. But now, wait a minute. Was that the local oscillator? I got this turned way down, speed-wise. So the speed of this is way down. There's no way that was... pretty amazing. Let's try different. Let's try a different. Oh my gosh, everything on the floor now. This will give me a little better range if I use this kind of input here. Okay, we're now 50 volts per division. Oh, top is missing. Okay, again, no ground connected for some reason. I think that's a smart thing to do. Here we go. Where's the top? I don't know where the top is. I stole this from the other one. Again, I've just picked kind of a random spot here. I don't see a thing at all. How's that happen? How's that work? Don't hear an effect. Don't see an effect at all. Well, I'm just, everything I do just raises more and more questions about why is that working the way it's working. I just change scope leads and I get a totally different response. How can that be? How can that be the case? Where'd that lead go? This has got a switch on it. ×1 and ×10. I should have operated the switch here. We're on the ×1. I could switch this to ×10, knocks it down a bit. This looks like a great big hum. That's what it is. Great big hum. So again, I've just connected to a random spire, so let's carry on here and see if we can get anything on here that looks like it's an oscillator signal. Anywhere at all. Anywhere at all. So that was the plates of the capacitor. There's just nothing there. No oscillator. It's really, I wish, if a weak oscillator would be easy to pick up on here. I'll just poke a bunch of different parts down here and see if anything shows me anything. These nice coils. It's just nothing happening. There's a transistor involved in this. Of course. Transistor. You can look at the 3 leads on this transistor right here. The 3 leads on that transistor right there. So there's 2 transistors on this circuit board. One is, who knows? Oh yeah, that's going to be fun. That'll be lots of fun. Okay. Do some more just general poking around here. So I think this brown wire is carrying the output of this circuit over to this circuit to carry on. So this should have the IF signal on it. So you can hear coming out of this speaker the result of injecting some noise into this point going through the radio. I still don't see any kind of anything there. I don't believe I can hurt anything by doing this. Lots of DC voltages in there. Looks like no local oscillator. if I injected my own local oscillator frequency into this radio in the right spot, would it start working? Would that prove something for me? And I got this totally wrong, and in fact it's over here. That's the input to the IF circuitry. If I send a 10.7 signal into here, it's an FM radio, so I think that's enough. I think touching it like this and sending the noise in is enough to prove that this part of the radio is working. It's all pointing back to the local oscillator. Can the switch be part of the picture? Band switch be part of the picture. Let's clean these switches and controls at this point. One radio I remember where the radio's behavior was horrible, and in the end cleaning, I'm sure it was the volume control, fixed it all, and I was stunned. So funny things happen with these things. Don't think that I'm going to get stunned here. So the switch is really packed in there. Okay, on the volume control, tone control, well, might as well do it. Switch, I don't know if I want to spray this into here. This is full of a material that doesn't apparently do well with WD-40 oil, so I'm gonna clean this guy out. Okie dokie. I'm gonna spray it right in here. Oh, let me put the knob on. Okay, now did that fix the radio? Switch off. Ooh. This light can start flying around. It's got it's got 120 volts on it. They've tried to insulate it as well as they could. Okay, have to keep an eye on this now because it's ready to fall out. Don't put your finger behind there. Are we ready? Once again, switch is off. Power on. 120 volts. Power on. Can't say that's sounding better. Let's try AM. Oh, okay, so I'm on tape right now. Funny it sounds like that. Ooh, that's radio. You know, we still got dirt in the capacitor. Maybe that's why the oscillator doesn't work. Okay, let's clean that up too. Okay, and do that with a little bit of a lubricant here. Usually if you're having this kind of trouble, you know, it's intermittent, you hear the scratchy and all that kind of stuff, but So whether it would actually quiet the radio right down, I just don't think so. So we want to get in here. And get the ball bearings up here. Okay, any difference? Only when the power is on. Scratchy gone? FM. The local oscillator is not oscillating. There's going to be essentially no signal fed into the front end of this radio. Let's give it something to chew on here. Sort of a way of proving the if I put a 10.7 signal into the front end of the IF and it comes out the speaker, this is an FM radio, so this is tricky stuff, that suggests that the radio itself is not putting the 10.7 signal at the front end of the IF. And again indicates something's wrong with the front end tuner. Again suggests no local oscillator operating. So to do the 10.7 thing, oh my gosh, I'm running out of leads. Let's use one of these backwards. You can use this backwards, can't you? Now the 110 switch, it's on 1. Let's put it on 10. And we want to set this to 10.7. That's what the IF is. I assume the IF is tuned for 10.7. Signal's low. Turn it up a little bit, and we have it padded down here. Okay, we flip the radio over. You can see its belly. 10.7. First, without grounding this. Right on here. So that's the 10.7 coming through. Even though I'm touching this circuit board, I'm just picking the end of this wire. So it's really going in over here. Let's try tuning the signal generator around. I'm going to turn it down. It seems to be, well, that's okay. Well, that seems kind of normal to me, what we just heard. So it's really telling me, again, quite clearly, if the right thing were on this wire, it would come out of the speaker. The wire is the problem. That's right. The wire won't let the signal through. No. Okay, theory now, local oscillator dead. How to find out why, or how to be absolutely certain. Wow.